More than 4 decades after its launch, Voyager 1 continues to travel through one of the least understood regions ever explored by humanity. Designed in the 1970s with technology that now seems incredibly simple, the spacecraft has survived far beyond its original mission, becoming the most distant human-made object ever built. When Voyager 1 lifted off in 1977, its primary goal was to study Jupiter and Saturn. Engineers expected the mission to last only a few years. Instead, carefully planned gravity assists from the giant planets accelerated the spacecraft toward the edge of the solar system, beginning a journey that continues today. Along the way, Voyager transformed planetary science. It revealed active volcanoes erupting on Jupiter's moon Io, captured detailed images of Saturn's magnificent rings, and provided measurements that reshaped our understanding of the outer planets. But those discoveries eventually became only the beginning of a much greater mission. After completing its planetary tour, Voyager continued traveling toward the outer boundary of the Sun's influence, a vast region known as the heliosphere. The heliosphere is created by the solar wind, a continuous stream of charged particles flowing outward from the Sun. This enormous bubble surrounds the planets and shields much of the solar system from high-energy particles traveling through our galaxy. For decades, scientists debated what would happen when Voyager finally crossed its outer edge, known as the heliopause. In 2012, that historic moment finally arrived. Voyager's instruments detected a dramatic increase in galactic cosmic rays while particles originating from the Sun dropped sharply. These observations confirmed that the spacecraft had entered interstellar space for the first time in human history. Yet one measurement surprised researchers. Many theoretical models predicted that the magnetic field beyond the heliopause would rotate significantly as Voyager entered the interstellar medium. Instead, the magnetic field remained more closely aligned with the one inside the heliosphere than expected. Rather than behaving like a sharp boundary, the transition appeared far more gradual and complex. Several years later, Voyager 2 crossed the heliopause from a different location and observed many of the same patterns. Together, the two spacecraft revealed that the edge of the solar system is not a simple dividing line but a dynamic interaction zone shaped by both the Sun and the surrounding galaxy. These discoveries did not overturn existing physics. Instead, they showed that the environment beyond the solar system is far more intricate than earlier models suggested. And the surprises were only beginning. Crossing into interstellar space was not the end of Voyager 1's mission. In many ways, it marked the beginning of an entirely new chapter in space exploration. Beyond the heliopause, Voyager entered an environment no spacecraft had ever explored directly. Scientists once imagined this region as a quiet, nearly empty expanse between the stars. Instead, Voyager revealed a place filled with invisible activity. Its instruments detected energetic cosmic rays moving through interstellar space, along with ionized gas known as plasma and enormous magnetic fields stretching across the galaxy. Together, these forces create a dynamic environment that continues to surprise researchers. One of the most important lessons from Voyager is that space between stars is not empty. Even in regions trillions of kilometers from the Sun, charged particles and magnetic fields constantly interact. These interactions influence how energy moves through the galaxy and help scientists better understand the environment surrounding our solar system. In early 2024, Voyager reminded the world just how remarkable its mission still is. The spacecraft suddenly began sending engineering information that no longer made sense. Instead of readable data, mission controllers received corrupted telemetry. At first, engineers could not determine whether the spacecraft itself had failed or whether its computers were experiencing a serious malfunction. Because Voyager is now so far away, solving even a simple problem becomes an extraordinary challenge. A radio command takes more than 20 hours to reach the spacecraft, and another 20 hours pass before a response arrives. Every decision must be carefully planned because waiting for results requires nearly 2 full days. After weeks of investigation, NASA engineers traced the problem to a section of Voyager's flight data system. Rather than ending the mission, they designed an innovative solution. Using parts of the spacecraft's remaining memory that had not been damaged, engineers carefully relocated sections of software and gradually restored communication. The recovery demonstrated not only the incredible durability of Voyager but also the skill of the engineers who continue operating technology built almost half a century ago. Today, every signal received from Voyager represents information from a place no other active spacecraft has ever visited. Its instruments continue measuring plasma density, magnetic fields, and high-energy particles flowing through interstellar space. Each observation helps scientists improve computer models describing how the heliosphere interacts with the surrounding galaxy. Researchers now believe the boundary around our solar system is much more dynamic than originally expected. Instead of acting like a fixed shell, the heliopause appears to expand, contract, and respond to changes in both solar activity and the interstellar environment. These discoveries continue shaping modern space physics. Scientists are investigating how magnetic fields connect across enormous distances, how cosmic rays travel through interstellar plasma, and how our Sun exchanges energy with the surrounding Milky Way. Importantly, none of these observations suggest alien technology or mysterious artificial objects. Instead, they reveal something equally fascinating. Nature is more complex than earlier theories predicted. Voyager's greatest contribution has never been proving extraordinary claims. It has been providing real measurements from a region humanity had never explored before. As its power slowly declines, mission controllers continue shutting down non-essential instruments to preserve the spacecraft for as long as possible. Every additional month of operation extends humanity's scientific reach deeper into the galaxy. Eventually, Voyager's power source will no longer support its instruments, and the spacecraft will fall silent forever. But its journey will not end. Long after its final transmission reaches Earth, Voyager 1 will continue drifting through the Milky Way for millions of years. Attached to its side is the Golden Record, a small time capsule carrying music, greetings, natural sounds, and images that represent life on Earth. Whether another civilization ever discovers it remains unknown. Its true legacy is already secure. Voyager 1 has become one of humanity's greatest achievements, a spacecraft that exceeded every expectation, survived for nearly 50 years, and carried human curiosity beyond the boundaries of the solar system. As it continues its silent voyage among the stars, it reminds us that exploration is never truly about reaching the end of the journey. It is about expanding the frontier of knowledge, one discovery at a time. And somewhere, far beyond the planets, Voyager 1 is still moving forward, quietly exploring a universe that remains far larger, stranger, and more extraordinary than we have yet imagined.